So the first thing I'm going to demonstrate in a little bit more detail is how this declination and right ascension mount works. So right now I have the whole scope in a storage position. You saw me pull it out of the garage. So now I want to get it set up as I prepare like I would at night, so that you see exactly how this is all set up. So the first thing I need to do is I need to balance the telescope. So I'm going to rotate this to its home position, which is pointing at geographic north. I've got a couple of index markers here already set up. And all I have to do is lock the axis. So the axis that I just rotated is called the declination axis. This is called the right ascension axis. This is the axis that actually tracks the rotation of the Earth. Now the first thing you're going to notice when I just loosen this is that this thing is really unbalanced. And it's going to want to go wherever it wants. And that's because I had to shorten the weight axis in order for me to fit it in my garage. So I have a procedure by which I will quickly attach an extension to this, and in just a minute or so I'll be able to completely rebalance the telescope so that it is perfectly counterbalanced by the counterweights. The extension here, I'll do that next. Now like this. And obviously you know what's going on. The more the weight is further from the center of gravity, the more it can balance the payload. Now the telescope weighs 27 pounds, and with all of the other accessories on it, the guide scope, the camera, and everything else, is closer to about 32. And then the actual mount rings weigh another 8. So this is quite a payload. So now I'm going to do the same thing I just did a minute ago. And you'll notice, if I adjust the weights just right, that it perfectly is balanced no matter what position it's in. So this is where I want to start off for the night. So I'm going to put this thing back into its home position in both right ascension and declination. Now, I rolled this platform out, but I really haven't done anything to level it, and I'll tell you in a minute how that leveling function works. But right now I'm going to talk a little bit more about what we have on the telescope itself. So this is obviously the main telescope. It's, like I said, it's a 155 millimeter refractor antenna. It's got a 90-degree eyepiece that goes into this setup here, and this normally terminates either in an eyepiece where I can look at an object, or I can put an optical camera. Next to this is what we call the guide scope, or the spotter scope. This is used to fine-tune when you're searching for an object in the sky. You coarsely put it into the crosshairs of this one, and then you tune it in, you adjust the position to this telescope. These are both bore-sighted, but this has a lower magnification. Oftentimes it's easier to find an object in the guide scope before you actually put it in the eyepiece. Once you have it in the eyepiece and you're pointing to the object, and you have the clock drive turned on with the computer, basically as the Earth rotates, you can track that object almost all night long. However, that optical tracking solution is absolutely essential on a couple of things. The first of which is that the platform is level and aligned. And this is where big optics platforms cause problems for a lot of consumers, because this base weighs 17 pounds, this head weighs 51 pounds, this weighs 30 pounds, this weighs 8 pounds. I've got 38 pounds of counterweight on here. Alright, you cannot pick this all up and move it at once. Normally someone would put out the base of the tripod, then they'd add the head, then they'd add the mount, then they'd add this, then they'd add counterweights. It's a very time-consuming process. It can easily take an hour and a half to 2 hours just to pull it out of your house or your garage if you don't have some kind of platform or base to move it like this. So by putting it on this platform, I've already forestalled the need to reassemble and disassemble the telescope every night. The second thing that I want to point out too is that this base has to be level. And while I know where the North Star is roughly in my area, because I've been out here so many times, and I have it roughly pointed north now, I would assume at nighttime when I would do this, that before I adjusted the wheels or anything, I mean it's fully able to move, as you can see, I'll be able to roughly see the North Star in the eyepiece of the polar telescope that goes along this axis before I start to level. So I'm going to assume that it's night, and then I've already looked through here and I can generally see it. It's close, but it's not nearly aligned. The first thing I need to do is to level the platform. And let me show you how we do that. Now before I level it, let's do a little tour of how I've had this set up. First of all, these essentially jars around the perimeter are just storing my accessories. My plan is to 3D print some storage. Haven't gotten around to that, so these are just attached by screws to keep them clean and out of my way when I'm using it. But basically, you see these three devices here. These are the leveling legs. There's one under each of the tripod CGs, and then the overall center of gravity is right in the center of the battery, right in the center of the platform. That way, despite the fact that this is a lot of weight and it's a big lever arm, it's impossible to tip this, whether it's on the wheels or on the stands. But right now, my driveway is sloped, and I need to figure out a way to get this platform level. So if you take a close look at each of the leg areas, and I'm going to scoot one up here and zoom in on one right here, you'll notice there's a series of levels. Let's see if we can zoom in there and you see it. There you see it right there. There's one on each leg, and the idea is to crank up the leveling legs to get the wheels off the ground, and then to level the three pads relative to each other. So as you have three legs, you have three levels. So this is a manual process. And since I have all this weight now on the base, that means that it's going to take a little bit of force to pull this off. So I can start this by squeezing these down until they kind of hit the ground, like that. And then one like this. And then like this. So those pads are just touching the ground, but they aren't doing anything right now. So what I generally do is I start with the wheel that is furthest upslope, which is this wheel right here. And what I want to do is I want to get that wheel off the ground. So I bring my wrench. Make sure it's tightened. And I start cranking. That a bit now, and what do you see here? I can spin the wheel, so I know I'm no longer on this leg. So I've now relocated the camera on the other side, so the wheel that's in the top of the picture here is the one that I just picked off the ground. Now I'm going to work on the next leveler, and as I do, I'm going to focus my attention on that particular little level right there. Because what I want to do is I want to crank that down until the two legs that I've already extended are now level. So this too will take just a minute. So this particular platform has a slightly different level than the platform that I left for you to work on, and I'll talk about that in a minute. But as I'm cranking down this pad, I'll start to see the bubble level move to the center position. So, as you can see, it takes a bit of cranking to do this. Okay, bubble's just moved, it's almost in the center. Keep going just a little bit more. So, that's now level, so this leg here is level to one another, but now I have to do the third leg. To do that, I need to pivot over to the last of the legs that I'm going to crank on. Let me back off a little bit so you can see what I'm doing, and then I'll be looking at the level next to it. So here we go. centered, that bubble level is centered, and that bubble level is set to where I need it to be. So the platform, this platform is now level, so I just use these screws just to kind of snug the bolt in so it can't shift on me. And it also takes a little bit of load, takes some of the load into the wood instead of putting it all in the bolt. So now the platform is level, and I'm ready to go through my 3-star alignment.
So you can see how the pads have lifted the wheels off the ground and that they're now taking the full load of the actual system. Those wires underneath are basically the interconnects between the lights and the power panel and the battery. Last thing I want to point out is a little difference in the levels that are on this system. This is called a center bubble level. You've probably seen these. These things only cost a couple dollars. So there's 2 center bubble levels on these 2 legs. This third leg actually has a different kind of level, and these are the levels that are in your cart. They're called slope levels. And the idea of the slope level is it's not supposed to be centered. It's designed such that the 0 line represents the point at which the actual leg is in 0 slope. So they're actually slightly more accurate. I don't have this quite adjusted here the way I want it, but I can easily crank that just a little bit more. But those are the levels that are currently installed in our platform. Let's talk about just a couple of other details of the cart itself. I haven't talked about the electrical load or the electrical system at all. Obviously, the entire system has a large 12-volt battery. It's a marine battery, which is meant to be recharged many times. Why did I choose a marine battery? For a couple of reasons, but I do share this battery with another function when I'm not using the telescope. But for the actual telescope itself, you don't need a battery nearly this big if I were just powering the telescope itself. But this system is actually designed to power 2 other accessories, both of them related to the telescope but in different ways. The first is an electric dew heating system. If you look just barely underneath on this side of the telescope, you'll see a little control panel right about here. It's got a bunch of knobs on the side. What that does is that actually powers these black strips on the top of the refractor as well as the guide scope. When you get cool autumn nights or even colder winter nights, you can get either dew or ice on your optics. This obviously, if not compensated for, immediately ends your session. So these devices, you can dial in some heating resistance to keep those optics just warm enough so that the dew will not form on the optics and allow you to continue to take data throughout a long cold night. Now, a dew heater, when all of the channels are on full, can easily draw 10 amps of 12 volt. The third accessory that's on this particular system has to do with the camera, which right now is not on the eyepiece, goes right here. But that particular camera has some data cables associated with it. Let me pull them out very quickly so you can see them. Those data cables allow me to network into the camera itself and connect it to a laptop. That's what this cable is, obviously, right here. But there's a couple others as well. One of these cables actually goes to a second guide camera that I can insert here that will allow me to take what's already very good tracking solutions with the telescope and then give it active feedback to basically get this telescope to track to plus or minus 1/2 of an arc second. But the second line, which is this little 12-volt line that's plugged in here, goes into the camera itself, and it's a thermoelectric cooler. It actually cools the camera down to 0 degrees so that you minimize the CMOS thermal noise when you're actually doing long exposure astrophotography imaging. So my power supply has to take care of all that. Now, there's one other thing it takes care of, which for me is not only a necessity or a convenience, but it's a necessity. And you can't see it here during the daytime, but with the power panel on, if I flip this switch right here, there's a series of shadowed red lights around the perimeter. I use those red lights at night so that I can read the levels during the auto leveling process. And then when I'm done with that, I simply flip the switch and those are off. So basically this 12 volt power goes into this power panel and it distributes the power to my telescope, to my thermoelectric cooler, and my dew heating system. And that's one of the reasons if you do a very long session on very cold nights, you're very well served to have a larger battery that can supply that current as much as you need.